So today we're going to be talking about new research that has unveiled the behavior of black holes on their feeding schedule when they eat off of star mass and grow bigger and stronger typical black hole behavior. But new research is showing kind of the behavior of black hole during their feeding schedules. Nothing much new on the Sky report. It's just a bunch of kind of old stuff that's coming to an end, especially since yesterday the moon was at a full and we see that waning and it's in the night sky. And more news on Ceres, as we know that Ceres has kind of been trapped. I believe it's in the Taurus. It's in or the Sagittarius T-Pal asterism. I'm getting those confused. But anyway, Ceres is starting to move away. That's happening this week. And finally, we're going to be talking about how more than 1,000 star clusters have been found in a starburst galaxy not far from here. And honestly, it's probably going to be like the world record for most star clusters in a single galaxy. Well, all of that and more coming. This is Interstellar Insights. Alright guys, so before I start off this episode of Interstellar Insights, I just want to say that I'm officially off my 3-week hiatus. I just had a bunch of personal and school stuff going on. So yeah, I'm just going to say that before this episode starts. I'll probably talk more about it at the end of this episode. But anyways, like I said in the intro, we're talking about the feeding schedule of a black hole and new research uncovered to kind of understand the behavior of a black hole as it consumes stars and planets and anything that goes in its path. So this has been done thanks to data observed by the Chandra X-ray Observatory owned by NASA and the Neil Gehrels Swift Observatory. They've both been analyzing a black hole named AT 2018 FYK, and if you cannot tell the obvious reason why it's named that, it's because they've been observing this black hole since 2018. So AT 2018 has been kind of the primary guinea pig, if you will, for understanding the feeding behavior of a black hole. And for context, this black hole is 50 million times bigger than the sun, and it is located 860 million light years away from us. So going back to 2018, the year 2018, when it was first observed, it was it was at this phase where it was pretty close to us in terms of viewing, which is what has allowed Chandra and the Swift Observatory to notice it. And from this, scientists have discovered that kind of like every 2.5 years, this black hole will kind of approach at this closest angle to us, which will allow us to analyze it for data. In this case, looking at the feeding schedule of a black hole. So in the case of AT 2018, we've noticed that whenever it consumes, a star enters its very strong gravitational field, mind I add, when we're talking about black holes, is that it'll emit a bunch of X-rays and UV light when it is done feeding off a star, which takes about it takes about a year or two for it to kind of finish its feeding cycle. And then once that happens, scientists have noticed that it will just stop emitting the X-ray and UV light because it's not, eating a star anymore. So that's helped us understand how black holes feast upon stars and, really understand us, the eating process and what goes on, especially since for those that are not familiar, everyone should be familiar, but for some silly reason, if you're not familiar with black holes, they're just very strong, very dense. They can bend gravity, and with that power, they can eat stars. So, and then once they eat stars, they get bigger, and then the whole cycle restarts. But this helps us understand really how black holes feed off of stars. So kind of looking forward, uh, the last time it's recorded second eating cycle was actually last year in August. So August 2023 is when the last last feasting cycle was observed. And right now there's obviously no X-ray, no UV return that's being observed. Now, scientists believe that AT 2018 will be back in close orbit sometime between May and August 2025 for Chandra and Swift to observe. And at that point, the third feasting cycle will begin. Now, with that being said, researchers are still going to be observing AT 2018, gathering more data, more about the feeding schedule. That's going to be very present and needed. So that's still going on. Who knows? Maybe we'll follow up on this if there's anything new that these researchers discovered. But yeah, that's everything about the new discoveries on the black hole feeding schedule. Let's go move on to this week's Sky Report. Alright guys, so welcome to this week's Sky Report. Of course, that's covering Wednesday, Thursday, Friday, 21st, 22nd, 23rd. Reminder that all these times assume are going to be in Eastern Daylight Time, unless I otherwise say it's like I think for this week I actually have some other time zones I'm dealing with. But anyways, remember I'll mainly be dealing with Eastern Daylight unless I say so otherwise. So if you don't live on the East Coast, go cry about it, do the math, whatever. Anyways, we're going to be starting out tonight. So I kind of hinted at this, but yesterday, was the full moon. And this morning, which is already past by the time this will be uploaded, is going to be at perigee, which is the farthest. Yeah. The farthest the moon is going to be at a certain point. Just happened this morning. And so tonight, by the way, this all leads up to each other because tonight the moon's back. So anyways, the moon is going to pass 0.7 degrees north of Neptune in the constellation of Pisces at around 6 p.m., Eastern Daylight. I don't know why I'm saying that. Which, if you live on the East Coast like I do, you guys should know that's pretty early and the sun's out. Which means it's probably better to wait until it hits 9 p.m. local daylight time. So that's whatever the local is. Anyways, you'll catch the moon and Neptune hanging out below the circlet of Pisces in the constellation. So, yeah, go out, watch it at 9 when it's actually dark, not at 6 p.m. Eastern Daylight Time when the sun's clearly still out. Anyways, that's today. Tomorrow, Thursday, August 22nd, we're going to be seeing Ceres, as I believe I covered this in July at some episode, but Ceres has been basically trapped in the Sagittarius teapot asterism in the south for a while, but now Ceres is preparing to go to its stationary point, which it will achieve August 26th, still in the future. So, future me is probably going to have to report on that. But anyways, I'm not trying to cause any time paradoxes. Anyways, it's going to change from a westerly motion in the Sagittarius teapot asterism to an easterly track towards its stationary point, once again achieved August 26th. I will probably talk about that next week. Future me will. So yeah, that is tomorrow night, Thursday, August the 22nd. Excuse me. Friday, August 23rd. So this August 23rd is special for everyone living in the western U.S. So for early risers in that region of the U.S., you can catch the transit of Ganymede's shadow early in the morning, as the shadow will kind of cross the southern polar region of Jupiter. So this transit is going to begin at 4:46 Mountain Daylight Time, not Eastern, Mountain. Big deal. The shadow is going to be, for Ganymede shadow, to correct myself, excuse me, is going to be first visible on the southeastern portion of Jupiter's, southern polar point, like I talked about, and this transition is going to take approximately 2 hours for the shadow of Ganymede to cross across the southern polar pole. Yeah, is it the southern pole? Yeah, like the southern polar region of Jupiter. I guess it's technically not its pole. But anyways, that'll take 2 hours. You can see the whole thing go if you choose to wait that long on like a telescope or something like that. But yeah, that's basically all the stuff going up in the sky for this week. We're going to some stats. So for today, sunset's going to be at 7:48 p.m. Moonrise is going to be at 9:04 p.m. Moonset's going to be at 8:26 a.m. Now for tomorrow, Thursday the 22nd, sunrise is going to be at 6:19 p.m. Sunset's going to be at 7:46 p.m. Moonrise is going to be at 9:29 p.m. And the moonset's going to be at 9:43 a.m. Now for Friday, August 23rd, sunrise is going to be at 6:20 a.m. Sunset's going to be at 7:45 p.m. Moonrise is going to be at 9:56 p.m. And the moonset is going to be at 10:59 a.m. Now, like I said earlier, for the moon phase this week, which is consistent all around for each of these days that I'm talking about, it's going to be a waning gibbous. That's as the moon is coming off the full moon, which occurred yesterday, Tuesday. So if you want to see that, you're going to have to time travel or something. Anyways, yeah, that's it for this week's Sky Report. Let's go move on to our second story of the day. Alright guys, so our last major portion of this episode is we're going to be talking about how more than 1,000 star clusters were found in a starburst galaxy. So for starters, these star clusters were observed in the accurately named Cigar Galaxy. And if you're wondering why, is because I looked at picture, and it's a very, very cigar-esque galaxy. It looks like a cigar, so whoever named it, good on you. Sorry for all the coughing, by the way. I've been kind of sick. But anyways, the Cigar Galaxy is a small, regular galaxy located 11.73 million light years away in the constellation Ursa Major. So, the Big Bear in the night sky. And then anyways, for those that don't know your galaxy classifications, like irregular, spiral, starburst. Starburst galaxies are galaxies that have a high star formation rate, which obviously means that this galaxy produces a lot of stars, which leads to the creation of star clusters. And then if you really don't know about what star clusters are just clusters of stars from a common origin that are just bound together by the gravity of each other, and they hold together for a period of time. So, for example, all these stars that are being formed in the Cigar Galaxy, they all come from there, which means that most of these stars just kind of meet up and they clump together by their gravity, thus creating a star cluster. That's just to help, clear up any vocabulary confusion. Anyways, observing the Cigar Galaxy create these star clusters isn't really new. Just for reference, in the past, 620 potential star clusters have been identified in the Cigar Galaxy, which was done years ago. But there's a new team of astronomers led by Rebecca C. Levy at the Steward Observatory in Tucson, Arizona, where they've been using James Webb's telescope's near infrared camp, otherwise just called NIRCam, to observe more star clusters that may be visible in the Cigar Galaxy. So, with this piece of technology, the NIRCam, off of the James Webb Space Telescope, Levy's team has been able to identify 1,357 potential star clusters in the Cigar Galaxy. So, once again, those are potential star clusters. Right now, there's a couple that I think got thrown out because they just didn't have too much stars or mass or density. Excuse me. Which let them being which led them being kind of thrown off the list of them being star clusters. So I don't know I forgot what the exact number was of like real deal star clusters, but who knows? And we know that there's probably going to be more because this team of astronomers is not done. Levy's team claims that they're going to be doing more research into finding more potential star clusters in the Cigar Galaxy, and then they're also going to be validating these potential star clusters as if they are actual star clusters or if they are fake and they're going off the list. So yeah, that's what's going on. Who knows? Maybe if there's like some, I bet there's some Guinness World Record for like astronomy. It's like, what galaxy has the most star clusters in it? It's probably the Cigar Galaxy at this point, because there's definitely because if so many stars are forming, that just means so many more potential star clusters are out there in the Cigar Galaxy waiting to be observed and classified by us here and by Levy's team in Tucson. So yeah, that's all I've got today for the star clusters found in the Cigar Galaxy. Who knows? Maybe there will be more research. Maybe it'll be like 2,000 or 3,000 star clusters when I return to visit this very, very cool story. So yeah, with that being said, let's go and move on to astronomy trivia. Alright guys, welcome back to astronomy trivia. Now, before I read the question, it's been 3 weeks since I did this, so we're going to go with the answer that was from 3 weeks ago, which I believe was, what is the closest star to the solar system? And before you decide to act all smart, like, it's the sun, that's just not true from the context of the question. I'm talking about other stars that are close to our planetary system. Of course, the sun is like the center of the solar system, so of course, obviously the sun is closer than any other star to us. Well, like we're talking about stars, outside in their own planetary systems, things like that. So with that being said, the answer to what is the closest star to the solar system is going to be Proxima Centauri. So for those of you that don't know about Proxima Centauri, is that this star is a very small red dwarf that is about 4.2 light years away from the solar system, which basically makes it the closest star to the solar system that is not the sun. I feel like there might be some debate with this answer because technically Proxima Centauri is a part of the triple system, the triple star system, Alpha Centauri, which is like 4.4 light years away, which is still pretty darn close. But with that Proxima Centauri is part of a system with Alpha Centauri A and Alpha Centauri B. I forgot what the star classifications are, but Alpha Centauri A and B are part of the Alpha Centauri system alongside Proxima Centauri. So I think it should fit in. I think it's pretty right. 4.2 versus 4.24. 4.2 is obviously smaller, meaning that it's closer to the solar system, but it is not the sun. So yeah, that is the trivia answer from 3 weeks ago, before I had a bunch of vacation and personal stuff to do. So anyways, let's get to this week's question. So for this week's question, the question is, what was the first planet discovered by a telescope in the solar system? I want to say that again. What was the first planet discovered by a telescope in the solar system? I'll put a poll up. I'll organize a poll on YouTube and Spotify for respective listeners to answer this question. And we will talk about that next week when I go for astronomy trivia next week. So yeah, that's all I've got this week for astronomy trivia. Let's go and finish this thing out. Alright guys, so thank you for listening to this episode. First episode I made since my hiatus. So yeah, I'm hoping to get back into the swing of things. Besides that, I'm planning on attempting to try and do shorts. I want to try and do that this week, but even the school has not started for me. I just have a bunch of stuff in my schedule, so I'll try to find some consistent pace to make. But anyways, besides the shorts, I have a bonus episode. Yeah, I recorded with my fellow friend Jeremiah Little. That'll be probably released this weekend. I don't know exactly. It'll be part of its own series, not a part of the official podcast. So yeah, hopefully we can get shorts done. Hopefully we can get this bonus episode out, and then we can hopefully chug smoothly until school starts, and then I start freaking out what to do. But yeah, anyways, if you like this episode of Interstellar Insights, I don't know why I stuttered. Feel free to like and subscribe. It would really mean a lot to me, supporting me. We can get some. With your support, we can get some better content on here, minus my very lovely voice that just, masquerades everywhere. But anyways, yeah, that's all I've got. So this is Interstellar Insights, and this is Michael signing off.